Have you ever stopped for a second and thought, how does lightning actually happen? Or how does a giant airplane, basically a flying building, stay in the sky? Or how does your brain keep your memories when it's literally just soft tissue inside your head? Ready? Let's break open the first how. Lightning starts with chaos inside a storm cloud. Imagine millions of tiny ice pieces, water droplets, and bits of frozen snow smashing into each other nonstop. Because of these constant crashes, the cloud starts acting like a giant natural electricity generator. Every bump creates a tiny spark, extremely small, but still electricity. These tiny sparks start to separate charges inside the cloud. The bottom of the cloud becomes filled with negative charge. The top becomes positive. The ground also becomes positive because the negative charge above pushes away electrons from the ground. This creates a massive electrical tension, like stretching a rubber band further and further. Eventually, the air can no longer hold the difference. Nature hates imbalance, so it fixes it the only way it knows, by releasing a giant spark. This spark jumps through the air, which normally does not let electricity pass, but lightning is so strong that it burns a path through the air, heats the air to something hotter than the surface of the sun, and creates that blinding flash. Then, the heated air expands explosively, and we hear thunder. Simple version: storm cloud fills with electric charge, charge becomes too big, electricity escapes, lightning. Airplanes look like they should fall because they're huge metal machines, but they don't fall because of something magical that their wings do. They create lift. Think of air as an invisible ocean surrounding us. When the airplane moves forward fast, the wings push against this ocean of air. Here's the simple magic. Wings are curved on top and flatter on the bottom, so when the plane moves, air on top of the wing has to travel faster and spreads out. Lower pressure. Air on the bottom moves slower and pushes harder. Higher pressure. Higher pressure pushes upward, and that upward push is what lifts the plane. If the plane slows down too much, the wings don't hit enough air to stay lifted. That's why planes need speed to take off and stay up. Engines do not hold the plane up. Engines create forward speed. Wings create lift. Together, they make flight possible. Simple version: engines make speed, wings create lift, lift keeps plane up. Your brain stores memories by forming connections between neurons, brain cells that talk to each other using tiny electrical signals. Think of neurons like tiny dots, and memories like lines connecting these dots. When something happens, a certain group of neurons activates together. They send chemicals and signals to each other. A connection forms. This connection is the memory. At first, the connection is weak, like a pencil line. But if you repeat the same thought, feeling, or action many times, the line becomes darker, thicker, stronger. The connection becomes easier to activate. The memory becomes harder to forget. Emotion also helps. Your brain loves important, scary, surprising, or exciting moments, so it makes those memories extra strong. That's why you remember your first bike ride, but not what you ate for lunch 2 weeks ago. Simple version: neurons connect, connection equals memory, repetition equals stronger memory. Your eye is basically a tiny biological camera, but even smarter than any real camera ever made. When light bounces off objects around you, trees, people, cars, tiny pieces of that light enter your eye. This light goes through the cornea, the clear front part of your eye. The cornea bends the light a little bit, like the first lens in a camera. Then the light passes through the pupil, which is the black circle in the center of your eye. The pupil works like a door that can open wider or make itself smaller. When you're in bright sunlight, the pupil becomes tiny to protect your eye. When you're in the dark, it becomes bigger to let in more light. Behind the pupil is the lens. The lens is a flexible, transparent piece that bends the light more precisely. It changes shape depending on how far the object is. If you look at something close, the lens becomes rounder. If you look far away, it becomes flatter. This automatic adjustment is called focusing, and your eye does it constantly without you noticing. After the light is focused, it travels to the retina, the screen at the back of your eye. The retina is covered in millions of tiny, light-sensitive cells called rods and cones. Rods help you see in the dark. Cones help you see colors.
These cells don't see images like a camera does. Instead, they turn light into electrical signals. These signals travel through the optic nerve into your brain. Your brain then takes all those tiny signals and assembles them into a clear picture, the image you see. Fun, mind-blowing fact: the image that lands on your retina is actually upside down. Your brain flips it without telling you. So your vision is half physical, half mental. Simple version: light goes in, lens focuses it, retina turns it into signals, brain creates the picture. Deep under the ground, far below the surface where we walk, the Earth is extremely hot, so hot that rocks melt into a thick, glowing liquid material called magma. This magma doesn't just sit still, it slowly moves around in giant underground chambers. As it moves, it collects gas, the same way a soda bottle collects bubbles when you shake it. The more gas the magma traps, the more pressure builds up. Now imagine this: the magma chamber is like a giant sealed bottle. The gas is like bubbles trying to escape. Pressure keeps rising and rising. At some point, the pressure becomes too strong for the rock above it. Cracks begin to form. These cracks act like escape tunnels. Once magma finds a path to the surface, everything rushes upward. Gas, melted rock, hot ash, steam, all bursting out with enormous force. That explosion is a volcanic eruption. Once magma reaches the surface, we call it lava. Lava flows down the volcano, cools, and becomes new rock. Over thousands of years, lava and ash stack up and create the classic volcano shape. Not all eruptions are violent. Sometimes magma oozes out slowly like thick melted cheese. Other times, the gas pressure is huge and the volcano explodes like a shaken soda bottle bursting open. Simple version: hot magma plus trapped gas, huge pressure, crack opens, explosion equals volcano eruption. Magnets might seem magical, but they're actually all about tiny particles inside metals. Inside many metals, especially iron, there are microscopic magnetic zones called domains. Each domain acts like a tiny magnet with a north side and a south side. But normally, all these domains point in random directions, which cancel each other out, so the metal is not magnetic. When you bring a real magnet close to this metal, an interesting thing happens. The strong magnetic field forces many of those tiny domains to line up in the same direction. Once enough of them line up, the entire piece of metal becomes magnetic too. That's why a metal paperclip can suddenly stick to a magnet. The magnet organizes the tiny magnetic particles inside it. Magnets also obey two simple rules. Opposite poles attract, north plus south. Same poles repel, north plus north, south plus south. The magnetic field is invisible, but you can see it when you put iron filings around a magnet. They line up in curved lines around it, showing the shape of the field. One more cool fact: if you heat a magnet too much or hit it hard, the tiny domains get scrambled again, and the magnet can lose its magnetism. Simple version: magnets line up tiny particles inside metal. When they line up, the metal becomes magnetic. Opposites attract, same sides repel. Spiders can walk on walls and even on ceilings because their feet are basically super sticky, but not in the way tape is sticky. Their stickiness comes from millions of tiny hairs called setae. Each hair is extremely thin, so thin that a single strand of human hair is like a giant tree next to it. On the tip of each hair, there are hundreds of even smaller hairs. Altogether, a spider might have hundreds of millions of these microscopic hairs across its feet. Now here's the cool part. Even the smoothest surface you can imagine, like clean glass, isn't actually smooth. Under a microscope, it has tiny bumps and pits. Each microscopic hair on the spider's feet can grab onto these tiny imperfections. One hair alone can't hold much, but millions together create a very strong grip. Spiders can stick and unstick their feet instantly because they control the angle of their legs. When they change the angle, they either press the tiny hairs into the wall so they stick, or pull them off the surface so they release. This is why a spider can run across a wall and then hang upside down like it's nothing. They don't use glue, they don't use suction cups, they use sheer microscopic physics. Simple version: millions of tiny hairs grip tiny bumps on surfaces, create super strong natural stickiness. Wi-Fi feels magical. You press a button and suddenly you're connected to the whole world. But it's just physics in action. Your Wi-Fi router sends radio waves, invisible waves that travel through the air, similar to waves used by radios, TVs, and phone towers. These waves carry information, but not in pictures or sounds. Instead, everything is broken down into tiny pieces of digital information, ones and zeros. When you load a video or send a message, your device turns the information into a pattern of ones and zeros. These numbers are then encoded into Wi-Fi waves. The waves travel through walls, doors, and furniture. They weaken a little, but they still pass through. Your phone or laptop has an antenna that listens for these waves. When it picks them up, it converts the pattern of waves back into digital information. Then the device reassembles the data into images, videos, messages, or sound. The whole process happens so fast you don't notice it. Even a simple tap on your phone sends and receives thousands of tiny radio wave messages. Distance, walls, and interference can weaken the signal. That's why Wi-Fi gets slower the farther you are from the router. Simple version? Wi-Fi equals invisible radio waves carrying tiny pieces of data. Your device catches the waves and turns them into the internet. Satellites stay in orbit because they are in a perfect balance between gravity pulling them down and speed pushing them forward. Let's break it down in the simplest way possible. Imagine you throw a ball forward. It moves forward, but eventually falls to the ground because gravity pulls it down. Now imagine you throw the ball much harder, so hard that as it falls, the ground curves away beneath it. If you throw it fast enough, the ball will keep falling, but it will never hit the ground because Earth is round. That's basically what orbit is, falling without ever landing. Satellites are launched with powerful rockets that give them enormous sideways speed, around 28,000 kilometers per hour, 17,500 miles per hour. At that speed, gravity pulls them down, but their forward speed keeps them moving around Earth, so they fall in a circle forever. There's almost no air resistance in space, so nothing slows them down. They just keep orbiting, staying above Earth because their sideways motion and Earth's gravity perfectly balance each other. Some satellites orbit close to Earth, some orbit very far, but they all stay in space for the same reason. They're moving fast enough to miss the Earth while falling. Simple version? Gravity pulls down plus high sideways speed equals orbit. And that's it. 9 big how questions explained in the simplest way possible. Lightning, planes, memories, volcanoes, magnets, Wi-Fi, spiders, satellites, all the stuff we see every day finally makes sense. If you want a part 2 or have more big questions, tell me. I'll explain anything you want in the simplest way ever. Thanks for watching. See you in the next one.